Hello, you are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. Today's section, we begin a new chapter regarding the study of human anatomy as far as, learn anatomy from this channel is concerned. Today, we want to commence our journey on what we call developmental anatomy. Yes. And so whenever we talk about developmental anatomy, we are talking about all those changes, okay, that is going to take place right from conception in your mother's womb. Yes. So of course, you reach, that adult stage where every, important structure, has, undergone that kind of attained that full development. Yes. Some other people may call it embryology, but whenever we say embryology, it's just a tip of the iceberg. Yeah, that's what I usually say. It's a tip of the iceberg because at the end of the day, there's more to it than just the embryology. Okay? Because one important thing that we have to know is that right from the time of conception, okay, before you get to the third week of intrauterine life, okay, we call it the pre-embryonic period. The pre-embryonic period. And usually from the third week of intrauterine life to the 8th week of intrauterine life, yes, that is the embryonic period proper. Okay, and of course beyond that, okay, beyond the 8th week, okay, from 9th week forward, we have what we call the fetal period. Yes, so one is delivered. But by and large, yes, whatever changes that is going to take place in intrauterine life period, yes, that's normally what we call embryology. Studying that aspect is what we call embryology. But as I said, you look at other things, okay? So we are going to learn a lot, okay, around this time. But for me to know, okay, whatever is going to take place till this time, then we want to look at an important aspect, okay? We want to look at gametogenesis. So today we are going to introduce you to something called gametogenesis. Now remember that whenever we talk about gametogenesis, it is how these gametes, okay, they are produced at the end of the day. Yes. And then whenever I talk about gametes, you are aware that we are talking about sex cells. And whenever I talk about sex cells, I am interested in the functional sex cells. Functional, yes. So those sex cells which are capable so that upon fertilization of the opposite gametes, we can produce that kind of totipotent zygote. That's what I'm interested in. That is capable of developing into a full-blown organism. That's what I'm interested in. Not just any other gamete. So we're going to see how these kind of juvenile, okay, will develop eventually to become the functional one from something we call the stem cells. And then we are going to see what these stem cells are. Now today, I want to just talk about gametogenesis. And then our subsequent meeting, next week, we will talk about oogenesis. Okay, so it's going to be a short video. But before I talk about gametogenesis, the first thing I want you to be aware is that we have something we call primordial germ cell. Primordial germ cell. Now it is this primordial germ cell which can differentiate to either become something we call spermatogonium. Yes. Now whenever you talk about spermatogonium, then it makes sense. You've learnt about the sperm, and whenever you talk about the sperm, we know that we are talking about the functional, the mature male gametes in human beings. Yes, you have the sperm. In the case of the female, we have something called secondary oocytes, yes, becoming something called ovum. Okay, so whenever you talk about oocyte, okay, they are going to develop via the process we call oogenesis. Now today, as I told you, we are going to talk about spermatogenesis. So let's begin and look at what I have for you today. But before I talk about how this spermatogenesis will take place, I need to tell you where this primordial germ cell, which will eventually differentiate to become oogonium, will arise from. And my friends, it's pretty simple. One thing that we have to understand is that we have various weeks, which we are going to see. But around the 2nd week of intrauterine life, okay, for now, just keep these points with you. Around the 2nd week, so we are looking at general embryology. We are looking at developmental anatomy and introductory bits. Okay, the important thing is that Now, the important thing over here that I want you to know is that around the second week of intrauterine life, there are some important cells. Now, remember that I told you that there are some stem cells, we call them pluripotent stem cells. If you are pluripotent, then it means that you are capable of differentiating into limitless, mature cells, so to speak. You are not limited, okay, unlike the multipotent or the unipotent ones. So for instance, this is what we are going to have. We have in the second week of intrauterine life, what you call the week of 2, there will be some two important cells over there. We have some cells, we call them hypoblasts below. We are going to see these things, but for now, then the important cell that I'm interested in is what we call epiblast. Epiblast, cells of the epiblast. So I have epiblast cells. Now, my friends, I have to be quick and tell you something. That I'm not talking about all the cells of the epiblast. Just some proximal portion of it. Just a small population of these cells. Proximal portion of the epiblast cells, which will go through some process, okay, which will be, going through some kind of streak, we call it primitive streak. At the end of the day, whoever you are, okay, you came from cells derived from what we call the epiblast. Through something we call encapsulation, I'm going to learn about all these things. But for now, just some population of the cells, the proximal cells in this streak, okay, which we are calling them epiblast cells over here, okay, in the second week, only in the second week. In the second week, that's where we see them. For this reason, I'm saying that these epiblast cells over there will give rise to something called primordial germ cells. Primordial germ cells. Primordial germ cells. So something we may just simply, yes, the PGCs, primordial germ cells. And what did I say? Which week? We are talking about the second week of intrauterine life. So around the second week of intrauterine life, with the help of the epiblast cells, we get the primordial germ cells. Yes. Now the point is that the primordial germ cells, okay, in this case, they become unipotent cells, which are going to give rise, okay, they are going to give rise to something we call gametogonium. Gametogonium. Okay, so the primordial germ cells will give rise to something we call gametogonium. So whenever I talk about gametes, we are talking about the cells, sex cells. So for this reason, it is this gametogonium, okay, which will either give rise, okay, we come to these things, but for now, just know that this gametogonium will have two fates. One of them is to either become oogonium Now, that's what I wrote, primordial germ cells. If they are cells, then it means that we won't get just gametogonium, but we will get gametogonia, so to speak. So the plural form of gametogonium will be gametogonia, so that you don't have the U-M, but rather you replace it with A. So this one also have the two fates. Okay, either will give rise to oogonia, okay, so the plural form of oogonium is oogonia, or it will give rise to something called spermatogonia. So my friends, keep an eye on this guy, this spermatogonia. That's what we are going to deal with today. It becomes a stem cell, okay, for these important things we want to see. So for now, that's what I want you to be aware of. In any case, this process will be halted for now. Why? Now the point is that these germ cells, they need a place to reside. Yes, they need a place to reside. Now, where are they going to? They have to go to the primary organs of the male reproductive system, or they go to the primary organ of the female reproductive system. And whenever you talk about the primary organs of these systems, we are talking about the gonads. Yes, you are aware of that. We are talking about the gonads. And whenever we say gonads, in the case of the female, we are talking about the ovary. In the case of the male, we are talking about the testes. Very important. Now, take that point. That once you produce this, it shouldn't come into the brain, neither should it come into the thoracic region, nor in your oral cavity. No. It got to go down there, got to go into your gonads. And whenever we are talking about gonads, we are talking about the ovary in the case of the female, and then the testes in case of the male. It's as simple as that. Is that okay? Good. However, now one thing you should be aware that these epiblast cells, through the primitive streak, they are those ones which are going to give rise to the definitive germ layers. Let me be quick and tell you something. This epiblast, okay, actually we call it, the primitive ectoderm. So cells of the primitive ectoderm, primitive. Now, it is the same primitive ectoderm which will give rise to the definitive trilaminar embryonic disc by way of the ectoderm, the mesoderm, the endoderm. Yes. So it means that this one hasn't differentiated to give rise to, of course, the other structures by way of giving rise to, of course, the gonads. So it means that this one should go and wait somewhere. The primordial germ cells should go and wait somewhere and wait until, of course, we produce the gonads. Because one thing I want you to be aware is that the gonads will arise from mesoderm. Precisely, some people call intermediate mesoderm. We will come to all these things. The gonads, by way of the testes and the ovary, where we will need these primordial germ cells to go and reside in there for subsequent gametogenesis to take place, hasn't taken place yet. Okay, it has to arise from what? Intermediate mesoderm. We have not produced it. So this guy, the primordial germ cells, will go and stay somewhere and wait until this one is produced. Yes, that same thing applies to life. Sometimes you may be taken from one place. You need to go to a particular place, but you may be hidden at a point before God will say it's time for you to go. Yes. So it is a matter of time. Yes, that's exactly what we see here. So it means that these primordial germ cells, God will have to give them a place to reside in the meantime before the gonads are actually produced. And where are they going to reside in the meantime? My friends, they are going to reside in something we call the yolk sac. Yolk sac. They will go and reside in something called the yolk sac. So they will migrate. Yes, from this point, from the epiblasts, okay, we've had what we call primordial germ cells. Now they will go into something called yolk sac. They are going to explain all these things for you. I will explain everything for you. But for now, get to know that the primordial germ cells will get into what we call the yolk sac. My friends, the migration from the second week. Now, for them to get to the yolk sac, it will take them, yes, about a week. So they will be there around the third or the fourth week. Third or the fourth week of intrauterine life. Yes, this is what is going to happen. It will take time. But my friends, that is not where it is destined to be. Now, in the wall of the yolk sac, that is where it's going to be. So it will stay in the wall of the yolk sac. But that's not where it's supposed to be. God said it should go into, of course, the gonads. So it will prepare the gonad. So that by the 5th week of intrauterine life, the gonads are ready to receive them. Yes, so it means that from here, these primordial germ cells will migrate again from the wall of the yolk sac. This time around, they will come into what we call the gonads. But let me be quick and tell you something before I write gonads. Yes, we are talking about gonads. But before you get gonads, gonads actually will not come out of blue. Yes, they will actually have a precursor which will give rise to the mature gonad, so to speak. This time around, we call it genital ridge. Genital ridge. So from the wall of the yolk sac, it will get to something called genital ridge. Importantly, this is where it wants to be. Because my friends, this genital ridge is the one which will have 2 feet. It will either become what we call, in the case of the female, it will become the ovary. In the case of the male, it will become the testis. Okay? And that is why we say that the ovary and the testis are homologous structures. Yes. Why? Because they have the same developmental origin. Okay? So that at the end of the day, the primordial germ cells, which will be the ancestors, so to speak, which will be the precursors to the functional gametes, okay, for the male and the female, okay, will of course come and reside in here, okay, and then eventually form them. That is one thing I want you to know. But around what point will they get into the genital ridge? My friends, this time around, it's around the early fifth week, okay, 5th week of intrauterine life. So my friends, these are key points I want you to be aware of. Just before I talk about the gametogenesis, okay? These are the important things that I want you to be aware of. So at this point, we are aware that this gametogenesis will take place where? In the testis. But my friends, precisely which area of the testis are we talking about? Yes. The factory for spermatogenesis, okay, is going to be something called the seminiferous tubules. So my friends, the first thing that we want to look at is where is this gametogenesis going to take place. So once I'm through with this one, we can now, actually begin looking at it. But there's one thing that I want you to be aware of, just before I talk about gametogenesis. Now, we've formed primordial germ cells. They've come into the genital ridge, having 2 feet. It's either going to become an oogonium or spermatogonium, which will either make it an ovary or a testis. Yes. This is where something comes in. I'll explain all these things in greater details later. But for now, one thing that you got to know is that there will be a gene. That gene is the determining factor. That gene is found in only male destined fetuses, so to speak, or destined male fetuses which are going to become, or embryos which are going to become, males. And something we call SRY gene. For now, SRY gene. So simply, we call it sex determinant region. Okay, Y gene. Sex determinant region, Y gene. So it's the one who is going to determine the sex of the embryo or the fetus. Yes. So that if you have this, okay, because of the Y, you are going to make the corresponding protein. So it will go to make sex determinant region Y protein. This gene will direct the production of that protein. And once that protein is made, my friend, the fetus or the embryo will automatically become male. If you don't have this gene, and for that matter, that protein is so produced, then you become a female. Yes, that's what happens. Okay, so for now, let's just go on to spermatogenesis. So what we are going to look at is spermatogenesis. Now I'm going to make it so brief for you. Spermatogenesis. Now my friends, unlike in females where we talk about oogenesis, in females, which I'll talk about next week, oogenesis will take place will begin, let me put it that way. Commencement of it will begin only and only in intrauterine life period, inside your mother's womb, in utero. Of course, to continue, okay, right in the ovary after birth, okay, then, of course, what do you call it? Around puberty, it will continue. Then eventually, it is going to terminate, finally, once fertilization takes place in the oviduct, in the fallopian tube, in the uterine tube, the sapiens, the one we talk about. Yes, that's where it's going to finish. But in the case of males, spermatogenesis will commence only and only after extrauterine life. Yeah, so it's after you come out of your mother's womb. After intrauterine life, okay, even around that time, yes, no gametogenesis will take place. It only commences after puberty. So that's the first point. Put that point down. Spermatogenesis will only and only begin after puberty. That's the first point. Yes. Now, unlike in females, where we have a lot of barriers, in the case of the male, we don't have the barriers. They are not really there. So we will see that. And what's the location? The location, I say in the testes, but precisely where? It will take place in the seminiferous tubule. So the first point, where is this spermatogenesis going to take place? It's going to take place in what we call the seminiferous tubule. In the testes. So that will be the factory for sperm production. Now the first thing we've seen it that from a primordial germ cell, it can give rise to the oogonium, but in the case of spermatogenesis, we will have what? Spermatogonium. So I need this spermatogonium as my real unipotent stem cell for spermatogenesis. So I need spermatogonium. But my friends, for now, one thing I want you to be aware is that the spermatogonium, which is the real stem cell, going to begin this spermatogenesis. We want to qualify it, yes. So this time around, we call it type A. Type A. And if you have another description, type A dark. Yes, so first point is that I have spermatogonium by which type? Type A. Type A dark. Now my friends, the first point. This spermatogonium is just like the body cell. You know, in humans, the normal somatic cells, the body cells, they are diploid. Yes. 2N, having the complete set of chromosomes. So for this reason, we say that this one is what? Is diploid. 2N. Now my friends, something happens. This spermatogonium, which is the type A duct, will undergo repeated mitotic divisions. Yes. Will undergo repeated mitotic divisions, several of them. Now, the repeated mitotic divisions will have two fates. Yes. When I'm type A duct and I undergo mitotic division, mitosis, I will give rise to another diploid cell, which is also type A duct. That's one fate, one of the points. Another point is that it can undergo mitosis, and this time around, instead of giving rise to itself, type A duct, it will give rise to type A. This time is pale. It's relatively lighter, its cytoplasm is lighter compared to that of the type, A duct. For that reason, we call it type A pale. So that's another point. So this time, assuming that we've undergone several minor divisions, we've had type A duct, a lot of them, but one of them which is going to commit to the pathway of spermatogenesis, okay, which we consider to be part of the spermatogenic series, is that we are going to get something called the same spermatogonium, no problem. But this time we are talking about type A pale, because it's a product of mitosis. Because it's a product, let me use the red to demonstrate. Because it's a product of a mitotic division, then my friends, you know that it's also going to be what? Diploid. Yes. Now, apart from that, this type A pale, when it undergoes mitosis, it will give rise to this time around type B. Type B. Now for the type B, we've not differentiated it into either it's dark or it's pale. No, just type B. It is only the A that we got to differentiate between them. Because the real stem cell is the type A dark. So that we get spermatogonium, yes. This time around, we are talking about type B, a product of mitosis, therefore it becomes diploid. Now, type B spermatogonium will also undergo mitosis. And this time around, it will give rise to something we call primary spermatocytes. Primary spermatocytes. Yes, primary, some people primary they write this way. So primary spermatocytes. And my friends, because I told you that this primary spermatocyte is a product of mitotic division, it reminds me that this primary spermatocyte will not be haploid, but it will also be diploid. Yes. Now, then the next point is that from primary spermatocytes, my friends, this time around, meiosis begins. Now, you are aware from the senior high school that meiosis is a reductional division. There are two successive divisions. Yes, mainly the first one is an equational, is a reductional division. So that at the end of the day, the number of chromosomes, the ploidy of this primary spermatocyte. So this time around, if it's primary spermatocyte, we are going to rather give rise to secondary spermatocyte. So from primary, you go to secondary. So you get what we call secondary spermatocyte. My friends, now I told you that this is the first meiotic division, so we have meiosis 1. Now remember, first meiotic division, meiosis 1. And meiosis 1 is a reductional division. So for that reason, the number of total chromosomes over here will be shortened, will be reduced to half. So that at the end of the day, this time around, we will get N. So haploid. That is where an interesting thing happens, which I have to tell you. These cells, okay, they form the epithelial lining of the seminiferous tube. Yes. This same epithelial lining, okay, is the one where it's giving rise to the functional gametes. So going through this kind of holocrine secretion, giving rise to these guys. there are some cells over there. They don't form the spermatogenic series. We call them the sustentacular cells. Now let me put that point down here for you. Sustentacular. So now the point is that whenever you hear the word sustentacular, sustentacular cell. Sustentacular. Now the word sustentacular, the word comes from sustain. For this reason, if you are a sustentacular cell, then your role is support. For that reason, we can call these sustentacular cells supporting cells. And my friends, these sustentacular cells, these nascent cells, they also have an eponym. Something we call Sertoli cells. So, you know, your teachers, sometimes you say, they are supposed to support you to learn. So, Sertoli cells. Now, Sertoli cell. The point is that I got to explain something briefly for you. In the test, if you take a cross section of the testes, you see a lot of these seminiferous tubules. Now look at something. I just want to sketch something out for you to demonstrate something for you. Assume there's one profile of a seminiferous tubule. What we will see is that we will see several population of cells coming. Okay, so it's from the base. Now, that's the base of it. Now, as I come towards this region, okay, so there's the base. So because there's the base, we say basal compartment. So this area that is up to here is the basal compartment. Now, as I move from the base and I come towards now, the central cavity over there is something we call lumen. For this reason, as I get closer to the lumen, this region around the lumen becomes the luminal compartment. So I have another compartment here, I call it luminal. So in the seminiferous tubule, where this spermatogenesis is taking place, we have what we call the basal compartment and we have the luminal compartment. But you know, sometimes because it's not exactly the lumen, you may not call it luminal compartment. It's very close to lumen. So for this reason, because you can do adduction, bring it closer to the middle of the body. So for this reason, specifically we call this area adluminal. Ad. So it's AD, adluminal compartment. Adluminal compartment, very close to lumen. Therefore, the basal compartment where it's further away from lumen can also be called abluminal. Abluminal compartment. Okay, so that is, one thing that we see. Now, the first thing that I want you to be aware is that the spermatogenic series of cells which are developing, eventually we are going to see the spermatozoon which is going to be formed. They will begin. So it means that this is how it's going to happen. So from the basal region, we are going to have type A duct. It will become in type B. Okay, now and that. Then you go to primary spermatocyte, then you go to second cell. So as they get more haploid and haploid, they will be getting closer to the lumen. Yes, that's what we see. Now, the important thing is that if you are diploid, now around here, over here, the seminiferous tubules over here, there will be some cells, okay, helping with that, some kind of, contractile properties. We have some cells, we call them myoid cells. Myoid, they are epithelial in origin. They have contractile properties. They may also have some capillaries around. Okay, they will be under one over here. These cells, they will be dispersed, okay, in there. So the area over here, we call it interstitium, connective tissue interstitium. And there will be blood vessels over there. Blood will be running over there. Now, haploid cells were not exposed to the immune system. So anytime product of the haploid cell gets into the blood, an immune response will be mounted to work against what we call those haploid cells. Yes. So unlike the diploid cells, the haploid cells are not safe. For that reason, there should be the need for us to get some cells which will occlude the product from the haploid cell from reaching the blood or the blood coming in here. And that is why God brought these Sertoli cells to do that for them, to give them that support. And these Sertoli cells, if I just want to sketch one for you, there are some cells which are columnar in nature, and then they bear some processes. Now, studies have shown that even the processes are not really constant. They may form and break it. So let's say this is the columnar cell. So there will be another one over here. Okay, so now the point I want to show over here is that these columnar cells, they are processes which they give off, okay, they meet and they form something called tight junctions. So my friends, the point over here is that adjacent Sertoli cells, they give off processes which are connected tightly by tight junctions. And my friends, you know tight junctions more than I do. Tight junctions are zonal occluders, so they will occlude. They will serve as a barrier so that they will. So now the point is that there are some males, they have compromised barrier over here. The Sertoli junctional complexes formed over here, which are tight junctions, which will form something called the blood testis barrier. Blood testis. So these tight junctions, they actually form what we call the blood testis barrier. Which one compromise? It can lead to infertility in males. Yes, because there will be that kind of autoimmune destruction of the haploid cells, okay, in there. So that's what we see, okay? That's what they are. So for instance, so now the point is, where are you going to see these Sertoli cells really forming the blood testis barrier? At the level where we are transiting from the primary and secondary spermatocyte. That's really very important. Marks that point where we really need the blood testis barrier. That's number one. The second point over here is that, now remember that these cells were diploid. Now I want to produce functional gametes which are supposed to be haploid, and they are going to go into the gonads, reside over there. So if you learned about meiosis, okay, in prophase 1, okay, in meiosis 1, the prophase over there, what we see is that there's that kind of crossing over, there's that kind of independent assortment. So my friends, it's at this point where we are changing from primary spermatocyte to secondary spermatocyte, which is of course meiosis, prophase. Okay, I mean mainly what we are going to see over here is that there's going to be something called independent assortment of maternal and paternal chromosomes. Yes. So it means that at the point over here, what is that stage? The stage meiosis 1, converting primary spermatocyte to become secondary spermatocyte, represent the stage for independent assortment of maternal and paternal chromosomes. Now what it means is that, for instance, you are aware that the male can either bring a Y-bearing spermatozoon or it can bring an X-bearing spermatozoon. They were together, diploid. So they got to separate into the gamete, into the functional gamete, by way of the, either becomes an X-bearing or Y-bearing. For you to do that, there's this thing that is taking place. Important. Good. Now, this secondary spermatocyte will also undergo, this time around, now look at it. It was primary, that's why I put 1 over here. You know, secondary, we put 2. You can see sometimes you see 2. So it means that meiosis 2 will take place over here. And this time around, we don't get tertiary spermatocyte. We don't have tertiary spermatocyte. This time around, we get something called spermatid. 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 And my friends, because the spermatid is also a product of meiosis, this time around we are talking about meiosis 2. And you know meiosis 2 more than I do, that meiosis 2 is an equational division. For this reason, if this is N, haploid, this one will also be N. Okay, so that is what we see for the, so let me see, it's N. Now this haploid, we have early spermatid, late spermatid. Okay, they usually circular, okay, oval structures. Then they begin to elongate, shedding some of the cytoplasm, using some kind of enzymes, going through some kind of programmed cell death, apoptosis. Yes, that's what is going to happen. So that the spermatid, okay, we will see what will happen to it. So that is what we see. So from secondary spermatocytes, we are getting spermatid through, of course, this meiosis that we're talking about. Now, my friends, from spermatogenesis, what hormone is responsible for all these processes? The hormone that I want you to be aware, we call it follicle stimulating hormone. There's a hormone, we call it follicle stimulating hormone. Follicle stimulating hormone. Now, from spermatid, the spermatid will undergo some kind of cytodifferentiation. And that cytodifferentiation is something we call Spermatogenesis. The cytodifferentiation, shedding the cytoplasm, excess, forming tail, gain a chromosomal cap and all that, okay, is what we call spermiogenesis. This time around, the main hormone that is responsible for this spermiogenesis is testosterone. Yes. Now it's undergoing spermiogenesis so that we produce what? So that we produce the functional spermatozoon. Which is also haploid. This one is not any, neither is it mitosis, neither is it meiosis, cytodifferentiation that is just taking place. Okay? Yes, that's what we see. Okay? To become, of course, that elongated spermatozoon, having that kind of acrosomal scale. When you look at fertilization, I'll explain, I'll draw all these things for you. Okay? So that's what we see. Now, is the sperm? So it means that the most functional, so in this case, we have what we call the, spermatozoon in here. And the spermatozoon, for them to come all the way into the lumen, there's an important thing I want you to be aware. The same Sertoli cells, they make some kind of protein. There's one protein that it makes. We call it androgen binding protein. ABP, androgen binding protein. It makes a lot of it. Okay, and what happens is that, my friends, apart from the epithelial cells, by way of the cells formed the spermatogenesis series, including, of course, these guys which are not stratified, these guys which we call them Sertoli cells, we also have some cells in the connective tissue interstitium, which can be singly placed. They can be in pairs, eosinophilic cells, they can be twos, they can be three, and what have you, clusters and all that. Those cells, we call them, it's also having an eponym, we call them interstitial cells. My friends, we also call them Leydig Someone's name begins with a capital letter. Leydig cells. My friends, these Leydig cells, they are those ones which are going to make the testosterone. Yes, they are going to secrete testosterone, concentrate them into a lumen, so that these haploid cells, by way of spermatozoa, will be pulled towards the lumen. When they come there, they will be hanging over there. So, for instance, let's say there is one spermatozoon hanging in there, another one hanging in there. My friends, that's not where they are supposed to be. They are not destined to hang in there. They are supposed to leave over here, go to the epididymis for storage, for maturation, and all that. For this reason, they will have to be pulled. So the high concentration inside the lumen, testosterone inside the lumen, will pull them over there. Remember that this same testosterone is the one which is helping in transformation of what we call a spermatozoa to become spermatozoon, which we are calling spermatogenesis. Also, it is also helping to release them from, of course, hanging in of the wall of the seminiferous tube. And that process of moving them from there, we call it spermiation. So another point over here is that once we form the spermatozoa which are hanging in there, they have to move. And by moving, the process is called spermiation. So with the help of the testosterone fluid, they will move all the way and go into what we call the epididymis. Now remember something, that the epididymis will have a head, it will have a body, it will have a tail. The head is very proximal to, of course, the testes. So that's where they will naturally be. Later they will go into the body, then later they will go into the tail. In other words, the most functional spermatozoon, let me call it spermatozoa, okay, will be where? Will be in the tail of the seminiferous tube. Yes, that's where they are going to be. And why should they go into the epididymis? Number one, they go into the epididymis for storage. So why in the epididymis? That's the answer you want to, the question you want to answer. Why should it go into the epididymis? So from here, why is it going into the epididymis? Remember that the plural form of epididymis is epididymites. So that it will become M-I-D-E-S, epididymites. Why going in here? For some function. Number one is for storage. They are going to be stored over there. Because, my friends, this guy is continuously producing the spermatozoon. Now, let me tell you that it will take, now, some authors say 64 days. Some say 72 days, which is very common. But even current studies tell us that it will take about 72 to 74 days. The better option should go with 74 days. Okay, that's what is going to happen. And my friends, if you take just one spermatogonium, type A, just one of them is capable of giving rise to a maximum of 512 spermatozoa. 512 spermatozoa. Now, please pay attention to the question very well. This spermatozoon can undergo about 5 to 7 repeated mitotic divisions. Okay? Now, if I take just one, if you trace its lineage, it can produce a maximum of 512 functional spermatozoon. Yes. However, if I take just, let's say if I take one primary spermatocyte, and I ask you, how many spermatids or how many spermatozoa will arise from it? That one you say 4. Because it should be meiosis 1. We are going to get 4 eventually. 4 daughter cells. But the question, you should pay attention. So it means that it's an unending process every time sperm are produced. So you can't store them in the testes. That is why God provided a storage site that is in the epididymis. But my friends, when it goes into the epididymis, it got to be reformed. Yes. And the reformation, what am I talking about? The reformation. I am talking about the fact that it is going to gain functional, that's why it's going to gain motility, so that I can move. So it's not only there for storage, but also for motility. To gain motility, so that I can move. Now, moving from the testes into the epididymis through the testicular fluid, the current moved it. Now, this time it wants to move on its own, gain motility. The third point is that the testicular fluid will have to be reabsorbed. For this reason, the term we use for that is for concentration of spermatozoa. Concentration of spermatozoa. That's another thing. Or you can say maturation. Okay? That is exactly what is going to happen over there. But the point is that all? Is that a final maturation for these spermatozoa? The answer is no, my friends. Because at the end of the day, this motile spermatozoon cannot fertilize the ovum of the female. The question is why? There are a lot of glycoproteins around it. Okay, it got to be taken away, got to be removed before it can really move with that energy. Of course, we know that mitochondria in the middle piece is going to support it when and of course fertilize this, of course, ovum, but it's not going to take place. It's not, I mean, it hasn't gained that functional capacity yet. My friends, the place that is going to gain that functional capacity is only and only inside the female reproductive tract. Yes. Without gaining entrance in there, this guy, the functional spermatozoon so-called, cannot fertilize anything. That is why in vitro fertilization, the assisted reproductive technology that is performed. Yes. So for instance, we have intracytoplasmic sperm injection. Okay, for instance, these functional spermatozoa in the epididymis, they go into the tail of them because that's where they will find the most functional ones. They will pick them up, but they have to be washed off. Okay, so in vitro, okay, removal of those glycoproteins over there before they can inject in there. That was the first one. So now the point is that for this reason, for that to take place, then we need the female reproductive tract helping with that in that regard. Now usually it may start every part of the female reproductive tract, but mainly we see majority of it taking place from the cervix, the uterus, but mainly where the final thing is going to take place, maximally, will be what we call the isthmus. Now the point is isthmus of the uterine tube. And that process of removing the excess glycoprotein, because we are making it capable of doing the fertilization, is something we call capacitation. Yes, making it capable to fertilize it. Okay, so that is one important thing that I want you to know. So my friends, this is the process I want you to be aware of. Males are type A dark, can always undergo mitosis, so there's always that kind of supply for these unipotent stem cells to give rise to eventually these functional ones. But there's one concept, you know, as you age, you may have some issues. You age very old age. I mean, people can give birth, they can, impregnate women and all that at very old age. But as you age and age, this repeated mitotic division, the telomeres, okay, will be getting shorter and shorter. With time, yes, there's that kind of, they become unable to, of course, undergo that kind of mitosis again, giving functional, gametes as these ones, okay, with time, okay. So my friends, this is what I have for you today. In our subsequent meeting next week, we will do that of oogenesis, you try to bring the dichotomy between the two. What are the similarities also? We look at them. And of course, we go into fertilization and of course implantation. I'm very grateful for your time this evening. Have a good night, all of you. And may the good Lord richly bless you. Amen.